All right, welcome to another edition of IAEI News Live. I got my green on. Today is St. Patty's Day. Happy St. Patty's Day to all of you out there. Where's my comments? There we go. We got Robert, and we've got David Englehart in the house. All the electric code nerds out there. Absolutely. I resemble that remark, David. Cleaning up after yesterday's, David, we have, I don't know, we had maybe about 6 inches of snow delivered to our area, but it didn't last. The roads are all clear, the sidewalks are clear, everything is clear. So, and Steve is in the house. I know it is something else, isn't it? All right. So, listen, what we're going to do is we're going to continue our journey in 2023 code change, or 2026. Man, I just went back 3 years. My name is Patty, Tom, and I've got Patty has his coffee, which is dripping. I thought I saw a drip. Yep, there it is. But get your coffee, get ready, because we are going to begin our journey into Chapter 3 of NEC 2026 on IAEI News Live, and it all starts now. No, hey, good to see you guys back. So I was just on another call, and I'm like, oh guys, I'm a minute late. I gotta go. So let's take a look at. I'm just going to open up, and you all know that you can get and download and purchase the code change book from IAEI, which I believe is, oh, my neck, way out of arm's reach, but that's okay. Let me do this. You can purchase that. Go out there to IAEI's website and get your copy of the analysis of changes. And we've got Wayne Janik in the house. Freezing in Chicago. I'll bet you it is freezing in Chicago, because here in West by God, Virginia, it's cold too. And usually, Wayne, the stuff that you guys get out there in Chicago comes our way. So, salute to you, and thank you for delivering such cold weather to us. And snow. Oh man, it's like a winter wonderland out there, because it's good wet snow, and I love wet snow. You can make snowmen out of them, put them in the front yard. I don't see any of my neighbors doing that, but that's okay. Wow, that is loud. I am going to lower my volume a little bit. All right, so I have to go to slideshow and set up slideshow, browse by an individual window, browse like a full screen at a kiosk. There we go. And I should be able to hit, I'm going to go down to Chapter 3. Oh, this is Chapter 3. And you know, Chapter 3 changes don't look like all that much, actually. I'm going to open up NFPA link. There's another thing. Another tool for your quiver is NFPA Linkarunos. So to get to NFPA link, let me do this. I think, therefore I am, monitor A. Hey, yeah, look at that. All right, so I'm going to go to NFPA link. Look at that. Up. NFPA link. I'm just going to do a search, because that's what I do. Oh, look at that. Bam. Chapter 3 is where we're at. So we're going to go into Chapter 3 as wiring methods and materials. Now, here's the thing about Chapter 3. You've got your general requirements in 300 and 305. And in 310, that's your conductors for general. Um, so you know what, David, I have not used Cassie on Link, and I'll tell you why I hesitate. I had an individual send me a note. Here's my hesitation. Um, Number one, I think we all have to understand artificial intelligence. We have to use it with a grain of salt. Take it with a grain of salt, because nothing can replace this and our knowledge of the code. But I'll tell you what happened was I had a person send me an email, and he disagreed with something I had written in an article. And he made the statement that Cassie, and he gave me the quote from Cassie, and honestly, it was not right. And it was around the motor inrush being, or motors being continuous loads. And Cassie said that motors are continuous loads if they last for 3 hours or more, and blah, 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 blah. And we don't use the term continuous loads in Article 430 for motors. It's a continuous duty motor and its continuous duty applications. We do not use the term continuous load, because a motor cannot be a continuous load because of the definition of continuous load. And there are terms in Article 430 that we use that are continuous duty, quote unquote continuous duty, and those are defined terms in Article 100. So since we don't use the term continuous load in Article 430, we use the term continuous duty applications, intermittent duty, and things like that. Cassie was steering that individual, and I'll tell you what, the email exchange that we had was one of those where they were taking what came out of Cassie as law, and it was just not right. So in any case, my message is just on anything AI related, don't replace this. Use any of these AI engines like Cassie and others, ChatGPT, I can name a whole list of them. Use them as an input to help you in your journey. It is not the end result. Okay, so just be careful of that. That's my only advice on that. Freddie B, inside and not out in the cold. Yes, nice day to be inside with the fireplace going and all that jazz. Del Rio, Texas in the house. Good to see Del Rio, Texas in the house. We got Josh the Sparky. I love the lightning bolts. All right, so let's get started. All right, and I can do this. Let's get started because we're going to take a look at 305. Remember, the way 305 is laid out. Let's take a look at how it's laid out. So you've got your general requirements. You've got your cabinets and your cutouts, your outlet devices, your medium voltage conductors. Then you've got all of these different types of cables and cable assemblies. You've got your conductor cables, your type IGS, MC cable, MI cable, NMC. And I would say it's very important, depending upon the conductors that you're using, to go to these articles. You'll find more information related to the proper application of the conductor that you are applying. Don't if you want to avoid how would I say it? Getting a red tag in the field, you're going to want to see the details around the conductors that you're using. NM, types NM is 334, ITC, etc. Once you get past the conductors, then you're going to get into all of your different raceways, your metal conduit, your IMC, your RMC, your FMC, liquid field, metal, or liquid tight, liquid tight flexible metal conduit, all of that good stuff. And then you'll keep going down, you'll get into your busway, your insulated bus pipe, cable bus, etc., wireways, your strut type channelways, your surface, etc. So these are all your cable trays and wireways and whatnot. Then you get into concealed knob and tube wiring. Yeah, I'm not even gonna. So I've had people say we should just get rid of 394, but honestly, there's still applications out there that have knob and tube. So I don't think you can. I don't think that's just as easy. It's easy just to get rid of stuff like that. Maybe a while from now, I don't know. Then you have your open wiring on insulators, all that good stuff. So chapter 3 is all about wiring methods and materials. That's what we're here to talk about. All right. So some of the changes, 300.1. Remember, code also drives 8-foot, not 8. What is, oh, I was like, what the heck did that come from? That was from a previous discussion. I forgot to hit the button. So just if you are using, if you use Ecamm software, which makes it real nice to put the comments up. You lost me. NFPA is using Cassie. Oh, what's this? NFPA is using Cassie on link instead of the old search. You know what? That's a good point, Fred. I might start using Cassie as the search engine because honestly, I'm not liking the search engine as much as I used to. All right, so I made a cappuccino just before coming online. The scope separated into 2 first-level subdivisions, and the table has been relocated. So this is one of those changes that I would argue. I would argue that this change is one of those things that it doesn't change how we're going to use the code. It's not a technical change. Except for 300.1b1. That's okay. So here's one of the things that changed. Remember, chapter 8 is used to stand on its own. And when it stood on its own, it would say the chapters 1 through 7, the contents of 1 through 7 would apply only when specifically called out in chapter 8. But they changed that in this cycle. And in fact, this change is a critical one because it is a reflection of that moving of chapter 8 into the rest of the systems. And if we go to the code and we go into chapter 1 and we go to 110.3, not 110.3. Why, Tom, would you go to 110.3? It's 90, chapter 90. 90.3. Code arrangement, 90.3b. Okay, so you'll notice that we have a chapter 8 called out, but it says that we pulled it into the rest of the code. It's no longer a chapter that sits by itself. So what you're going to see now is in the NEC, like what we're looking at in chapter 3, a change had to be made to recognize this modification. And some of the things that were moved in to the rest of the code, in addition to the fact that chapter 8 is no longer an independent chapter, some of the requirements now moved into other areas of the NEC, and chapter 3 is one of those areas. And 300.1b, I am just going to If I go to 300.1b, 300.1 scope, A is what's covered, right? This article covers general requirements for wiring methods. And what it says in B, this is good stuff. This is good stuff. I'm talking about, somebody mentioned code nerds or code whatever. This is magic right here. So what it tells you in chapter 3 is what's not covered is your class 2, class 3, class 4 circuits, optical fiber systems. Optiker is a technical term too. Communication systems, antenna systems, community antenna systems, network powered broadband, premises broadband, and power limited fire alarm systems. Where do you think the class 2, 3, and 4 requirements are found? That is going to be in chapter 7, because it goes to 11. And if we go to 7, I think it's chapter 7. Is it chapter 7? Yeah. Man, thank God. I went off memory there. So if I look at chapter 7, your class 2 and 3 is 725. Class 4 is 726. Class 1 and power limited is 724. So what would have been nice in that 300.1, what would have been really nice is if they gave us a table. And let's go back. They did not. It would have been nice to have a reference table for what they said does not, in the scope, when they say what's not covered, class 2 circuits, if they would have put a paren that said article blah, 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 class 3, article blah, 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 class 4, article blah, 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 that would have at least told you, hey, go look in those articles for the language for the requirements for that portion of the code, for those types of circuits. Oh, is that delicious? Okay, so let's go back to the slide. Oh, I'm not showing you the slide. So it says limited energy systems 300.1B1 was added to reflect the changes made in chapters 7 and 8 for limited energy systems, and we just saw that. So you see it's pointing to, it's just saying that chapter 3 doesn't apply to those class 1, 2, or 2, 3, 4, whatever, because that's all in chapter 7. So there's a table. 300.1 Charlie has been relocated to 300.19b. Let's take a look at that. 300.19b. There it is, metric design and trade sizes, metric designators and trade sizes. So let's do an expand. And I learned this on, I think, this channel from one of you or many of you out there, that I can hit pin header, boom, and now when I scroll, I don't lose my header and I don't have to scroll too far. So this just tells you the metric designator and then the trade size for each of the conduit and tubing that's associated with it. So that's the table that they relocated, and it looks like they added raceway fill, the number and size of conductors and cables. Complete raceway shall not exceed the allowable percentages in table 9. So they moved some stuff around. So the section in the table 300.1c has been relocated to 300.19. So, and I think my message there, the story is not we just moved this stuff. The story here is the fact that chapter 8 is no longer independent. They moved it into the rest of the book. The low voltage power or the power limited circuits are moved into the chapter 7, and they had to put this exception in to say that, hey, these These systems are now covered in Chapter 7, even though because we've moved them from Chapter 8 into the rest of the book. Be mindful, they're not covered under Chapter 3, they're a Chapter 7 issue. So that's my story there, and I'm sticking to that. Now I've got to figure out why I can't change my slides. All right, let's go back to this. Look at that. Can't move. It's a no. I think it's what I did in this setup. Browse by an individual window. Let's try that. If I do this, yep. Now I can change. Whew! Aren't those beautiful wires? And look at that insulation. Red, yellow, blue, and green. 300.4. Delish. All right, put that down on the side. Okay. We're dealing with damaged conductors now. Overheating, fire damage, corrosive, water. There is an evaluating of water damaged electrical equipment and then evaluating fire and heat damaged electrical equipment reference. So it's important, I guess, you have guidance now in 300.4c for conductors that may not be suitable for use for the applications. Now, what I'm curious is how 300.4c, so you have the voltage, the temperature, and then you have this new section, damage conductors. So conductors and wiring methods that are no longer suitable for use due to damage, such as overheating, fire damage, shall be replaced. What it doesn't say is that you can't install them. Opportunity. I would say there's an opportunity here. Because not only should you replace what's existing, but you should also have a requirement that says you shall not install. Watch this. org/70 next. And we're going to go to submit a public input online. I'm going to log in as me. And we're going to go to Chapter 3. Oh, service unavailable. I find sometimes when I hit refresh, it works. I'll tell you if it comes back. I think NFPA, what do they call that? TerraView is a little grumpy today. I was going to submit a public input, and it's coming back. So what we'll do, yeah, there we go. It's back. Whoa, where's it at? All right. So if we go to Chapter 3, and I haven't been looking at the comments. Michael Hofkin, cabling is 722, specify, okay. All too important to get a correct answer. Yes. Inquiries is all too, yep. I don't really like the AI. Okay, so we're talking about the common sense. Everyone would have it. Good afternoon, Larry Griffith. Good to see you, buddy. All right, so what we're going to do is I'm going to go to Chapter 3, and I'm going to go to Limitations, and I'm going to select this. I'm going to revise the existing, so you're going to get to see. We'll walk through the process of submitting a change. So I'm looking at it saying, in my opinion, I think that we should also, conductors and wiring methods that are no longer suitable for use due to damage, such as fire, shall be replaced. Shall not be permitted to be installed, and if installed, shall be replaced, right? And I'm going to hit next. It's going to show me my change in legislative text. So water shall not be permitted to be installed, and if installed, shall be replaced. I'm not sure if that's great language, but it makes sense to moi. And then in my substantiation, I'm going to say this section was added to address damaged conductors that are installed in an application. This public input seeks to ensure that these damaged conductors are not used in an installation. Okay, so I'm just going to leave it at that, because we substantiated the fact that it had to be removed. So I'm not going to go and rehash the substantiation as to why you should not be able to install them. If you've got to remove them, if they're installed, you should blah, blah, blah. Anyway, there's my information. I'm going to hit next. By checking this box, I affirm that I'm relinquishing my copyright and all that good stuff, and I'm going to hit submit. And there it is. I can view it. I can save it as a Word document, download it, and here's what I do is I go to, whenever I save it, this is 300.4 Charlie, $15.99, 300.4 Charlie. So I do 300.4 C PI 1399. I think it's PI 1399. 1599. PI 1599. PI 1599. And then I take that and I do a Control C and I put it over into an area where I have all of my public inputs submitted, and I do a V. There it is. And we just submitted a public input together to make that happen. So anyway, let me look at some comments. Boom. 300.4C makes reference to NEMA GD2. How do you get that? How do you get that reference? Freddie B. All right, here's what you do. This is what you do. You do NEMA GD2. Evaluating fire and heat damaged. I click on that. Boom, look at that. And there it is. And what I will do is Control C, and I'm going to put this, Control V, in the chat box so you can download that. It is a free document. It has all of the information, motor control centers, and let's look for conductors, cables. Wire and cable. When any wire or cable product is exposed to a fire or extreme heat, all components are subject to damage. The conductor, metal, and or insulation may be damaged, causing failure or premature failure. Wire and cable must also be damaged due to the water exposure, blah, 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 blah. Right? So there's your wire and cable, there's your conduit and tubing, all that jazz. So hopefully that helps. And then you could do the same thing for GD1. So if I go NEMA GD1, evaluating water damaged electrical equipment, there it is in a beautiful ocean blue and all that jazz. And then we have all of the equipment. So I will also put that in the chat box. Josh, wow, that was easy. Yes, so hopefully that helps, Fred, and all that jazz. So I would say that just do a quick search online, and it's there, and it's easy and it's free. And I'm going to lighten my system up here. So not too bad. Robert says, will this overheating of conductor damage include overheating from arc flash incidents? Conductors see that heat also. Wow. Here's my comment on that, Robert. So, that's a very good question. If you're looking at the conductors that feed a piece of equipment that has experienced an arc flash event, that's one thing. And yes, you will have damage at the ends of that conductor. I don't know how far back that heat exposure will be. But then the next question that you have to ask is, if I have raceways running next to the equipment, will the heat be enough to damage those conductors? And I have an opinion, which means absolutely nothing, by the way. But in my opinion, I don't know that the heat is there for a duration. If I have a raceway with conductors next to a piece of equipment that has experienced an arc flash event, the engineer in me says that I don't have a duration of heat that would transfer to that raceway to damage the conductors inside that raceway. Most often, if you're dealing with an incident energy application, then my gut, that's what my gut's telling me, Robert. But definitely the conductors that are in that equipment, yeah, I mean, it's going to be a very hot. There's going to be a lot of fire, flame, and whatnot. But the nearby equipment, that's questionable. And I think you would probably need to get somebody, ow, a lot more qualified than me. Oh, I just hurt my knee. Wow. Oh. Anyway. Oh boy, I hurt my knee. Okay, so I am going to close that. Queso, that's cheese. And I'm going to go back to the PowerPoint. So overheating, fire damage, great question on how do I determine that I have had damage, regardless of the reason. Because of, like, for example, I was in a house down in Alabama that had burned. A portion of the house had burned. And the question that the inspector had for me, which was a good question, as we walked through the house that had seen a lot of smoke, soot, some of it had seen heat. The question that we had to us say together, because he asked me and I know he knew I didn't have the answer, but we both had the same question. At what point do we declare all of these other exposed light fixtures, switches, other electrical products that are installed as part of the infrastructure, how do you know whether or not they've been damaged? Soot carries with it materials. If soot gets on exposed parts, and remember, I can have something that's installed that still gets into, because air is being pulled. Like if it's in an attic way, you could have the air being pulled up through a fixture, or I call it a fixture, a luminaire, right? So luminaires can be damaged, light switches, contactors, things like that. Anything that can take that soot in, or the smoke that carries with it those particles, you've got to think about. And the hard part is, how do you know when enough is enough or too much? So that's the $1 million question. And I would say there's probably a more qualified person than me to make that call. Freddie B, would insulation resistance testing be adequate to determine the damage level? Would insulation resistance testing? Yeah. So you're talking like high pot testing. I would say that's a very good. Now, when you've got to be careful with that, because you've got to disconnect things that you could damage due to which people out there probably already know this, but follow the right procedures when you're doing the high pot testing or insulation resistance testing, so that you don't damage equipment. But that yeah, very well could be, in my opinion, that's a great start, especially conductors, right? If you do the insulation testing on a conductor, you know that conductor has some integrity. That would be my say, but you know what? I'm not the conductor specialist. I'm not the conductor guru. I would go to a conductor manufacturer, which I'll tell you what I did. This house, I had some water damage because of some minor leaking issues that went on conductors. And I wasn't sure about the conductor itself. Before my insurance agency, State Farm, came in, I wanted to be sure. So I called a wire manufacturer, told them what happened, and I got some really good guidance from those individuals to help me determine whether or not my conductors were in jeopardy. So, and there was mostly NM wire because it's a dwelling unit. But I immediately called the manufacturer. Now, I have the benefit of knowing people in various companies because of my involvement with NEMA, but you have a NEMA field rep in your area. And then if you don't know who those individuals are, this is what you do. You go to your search engine of choice, and I just go to the main bar. I type in NEMA field representatives. Look, I've done this before. Technical field representatives. Here they are. There's your districts. You've got a map that shows you where they're located, and these are your individuals. You've got Mike Stone, Brian Bowman, Mr. Wages himself, and Jack Lyons, 4 key individuals that are critical. When you have an issue in the field, you can call these individuals. They're in, based upon which state you're in, send them an email, give them a call, pick up the phone, act now, and they will help you get in contact with the right people to give you the best guidance that you could possibly get. Damage is damage, right? It is connected to the terminal, and this is the milliseconds up to the 35. Yes. Now, if you're dealing with the conductors that are going into the equipment that has had the arc flash event, absolutely, you have damaged conductors. But here's the question, Robert, that I don't know the answer to. Is it possible to go back so far from that damaged point, put a box in, make a connection, and only replace a portion of the entire feeder? Do you know what I'm saying? So I just like, for example, in the house, in when you have a water damaged in a house, they will remove so many inches of drywall from the floor and they'll replace that. And then there is permission. Remember, there was specific changes in the National Electrical Code to permit a specific type of connector that is permitted to be behind the wall. Remember, typically splices have to be exposed, but there is a type of listed product, and I don't know the details. I bought some for downstairs for an application that I had downstairs when I was moving some things around. They are listed so that they can be placed behind sheetrock, okay? And you don't need to have them exposed and ready access to them. So there was a provision, and that was specifically for replacing portions of conductors. So now my question is, Robert, would it be possible to only have to replace a certain portion of the conductor instead of the entire conductor? Now, the benefit of having raceway and conduit is I can just pull it out. Makes life a lot easier. But I would ask, and I would probably ask the conductor manufacturer, based upon the incident, what portion of that circuit is damaged to meet these requirements that are in Chapter 3 with regard to damaged conductors. Because it says conductors and wiring methods that are no longer suitable for use due to damage, such as overheating, fire damage, shall be replaced. Could it be a portion of the conductor? I don't see why not. I'm not qualified to make the call on what is and isn't considered damaged when it comes to a conductor, but I'm sure that with the help of your NEMA friends and family, they would be willing to, and UL Solutions or Intertech or any one of these nerdles could probably come out and take a look at it. Fred says the E-inspector standard is any fire in dwelling is an automatic call that wire is suspect for damage requiring replacement. So it would be good to know exactly when a conductor is beyond reuse. Yeah. And that's the $1 million question. I think it's a challenge for that call. And it's a very important call because that would be, that could be very financially burdening. Installation testing should be done even periodically. What standard, ANSI or otherwise, could be referenced? I would go to NFPA. If it was me, Robert, from Omaha, I would go to, if I go to NFPA link, this is the other power of NFPA link, and you right mouse click, open in a new tab. Then you go to that new tab and you select NFPA 70 Bob for B. Your question was insulation testing. If you go to Chapter 7, Fundamental Tests, and you go to, look at this, insulation resistance quality, boom. Insulation resistant. For equipment rated up to 1,000 volts, the quality of electrical insulation resistance shall be verified using a DC insulation resistance test set. Insulation resistance testing. The applied tested voltage shall not exceed the value specified by the manufacturer. Call the manu. Where manufacturer's values are not available, blah, 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 in part of the industry standard, the test, with an appropriate industry standard. And there's no informational note. Good question. The test instrument used, okay, for equipment rated in excess, that's all it says, an appropriate industry standard. So, Robert, what standard, ANSI or otherwise could be referenced? 70B doesn't even reference one. So, who am I to tell you? I don't know. That's a good question. And I'm going to take it's getting sunny out. Hopefully you're wearing your Irish green, and tonight is green beer night. So, you gave me homework now, Robert. Now I'm going to go to bed tonight wondering what test, what industry reference, what industry standard would be the right one. But I agree with you. It is rarely, I think you're right, it's rarely done, but probably should be periodically done, especially if you've had a fault in your power distribution system. You should, now there's probably a cutoff in the ampere rating and things like the size of the conductor. You know, the cost of replacement is usually a driver for the cost of maintenance, right? That's like on a motor. I might have a very small motor. I'm not going to put a lot of monitoring equipment on it. I'm not going to take a $200 motor and put $3,000 worth of protection on it because I can just buy another motor when it burns up, right? So, but I take a motor that cost me, $100,000. I'm going to put $3,000 worth of monitoring on it for protection, so I don't have to replace a $100,000 motor. You get my drift, right? So the same thing with a lot of the testing, in my opinion. I don't know. There's probably people out there that'll tell me, Tom, that safety is more important. The cost of the replacement is not as important as the safety related to monitoring the equipment, monitoring that conductor, because if it fails, it can create a shock hazard, an arc flash event, etc., etc. And you could be very well right. Every application is going to be different. But suffice it to say, 300.4 gives us more information. Now, another change is right here. This is another change in Chapter 3. They made a modification. Remember this journey that we went down when we dealt with corrugated steel. And we said that conduit raceway can't be run within the corrugation. I can't remember what code cycle that was in. But we made this commitment to the industry to say, look, if you have these corrugated metal roofing, you can't run inside the corrugation, the valleys, because you can have a screw penetrate and go through the metal, through your raceway, and into your conductor. And there was evidence of that happening. Well, this section in 300.6 recognizes that, look, it doesn't have to just be the metal corrugated roof decking. I can have a wooden roof decking that and that has this, that presents the same hazard. So why pick on one construction method when other construction methods have the same issue? So they removed that metal corrugated reference, and it's not just cables, raceways, and boxes, but they just said wiring methods and equipment, because it's any wiring method and equipment. And then they had to also say, all right, if I have this, even if it's corrugated, if I put a corrugated metal roof up and then I pour cement on top of it, there's no way that I'm going to drive an anchor through the concrete and through the metal raceway and or through the corrugated steel and into your metal raceway or plastic raceway or whatever wiring method it is. So they also addressed that if you have at least 2 inches of concrete poured on top of that. I wonder if they used concrete. Willie Snyder in the house. Welcome to the party, brother. A little late. He may be late, but he's worth the wait. I don't know. Let's take a look at 300.6E. Because I'm wondering if it says concrete, because there could be other wiring methods and materials shall be permitted in concealed locations where encased in concrete, not less than 2 inches thick. Boxes and conduit bodies shall be installed in accordance with 300.14.29. Wiring methods and materials shall be permitted where encased. Okay, so that's if I'm putting the raceway. Exception number 2 says where metal corrugated sheet roof decking is covered with a minimum thickness. Well, that's previous language, so that exception was already there. The new exception is when the raceway itself is encased in concrete not less than 2 inches thick. Now, what it doesn't say, wow, here's my issue. Oh, so let me ask you a question, Willie and Robert. When I say encased, in concrete not less than 2 inches thick, if I have a 2-inch thick raceway and I have 2 inches worth of concrete on either side of it, that wouldn't be encased, would it? Encased. Let's do Merriam-Webster. If I go to Merriam-Webster and I search encased, encased, encases, to enclose in or as if encase. Ice encased the trees and power lines after the storm from a distance. So here's my question. Do I need 2 inches on top and bottom of the raceway to say it is encased? Is that what I'm saying? That I need 2 inches on top and 2 inches on bottom, and the raceway has to be in the middle? Can I have just 2 inches on top and the raceway be on the bottom? But to say encased, I have to be in the concrete. And my question is to all of you, does that mean I need 2 inches on top and 2 inches on bottom of the raceway? Or does that mean that I have to have a raceway that's just in the middle of 2 inches worth of concrete? And the gap on the top and bottom, can it be 1/4 of an inch? Can it be flush with the top of the concrete? I don't know the answer to that question. Fred says, Fred's yelling at me. Encased is completely surrounded. So Fred, can I have... Oh, I can't get my iPad. My iPad is not accessible. Double click. It's not working. My iPad is not working. Oh, wait, here we go. Thomas's iPad. Okay, so here's my question, Fred. Here is my question. Are you ready? So, if I have raceway, look at that, perfectly circular, and I have and let's say that this is 2 inches. This is 1/4 of an inch. This is 1/4 of an inch. Is that raceway encased in 2 inches of concrete? Or do I need this? Duplicate. Or do I need this? Oh, let's do this. Duplicate. Duplicate. All right, so do I need this? 2 inches? 2 inches. And that would make this, and let's say that this is, I don't know, 4 inches. That would make this 8 inches worth of concrete. Encased is completely surrounded. So we got that. Willie says, I would say 2 inches on either side because a minimum cover is 0 inches. Because minimum cover is 0 inches. So is a 2-inch conduit would need 6 inches of concrete. And that's basically, so if I did this 2-inch, 2, 4, 6, that would be 6 inches. So I would agree with that, because now my basic question is, does this language say that? It says wiring methods and materials shall be permitted in concealed locations where encased in concrete not less than 2 inches thick. So the concrete has to be 2 inches thick. And in that case, my concrete, we'll do this, and I'll say concrete. My concrete is 2 inches thick, but I've only got a 1/4 inch on either side of that concrete. So my 2-inch conduit, I'll say 1.5 inches. My 1.5 inch conduit is encased in 2 inches worth of concrete. It doesn't say that the wiring method and material has to have 2 inches of concrete on either side. Do I smell another public input coming on? Travel Holderman. He may be late, but he's worth the wait. And so Willie says a 2-inch conduit would need 4 inches. A 2-inch conduit would need 4 inches of concrete. So that would be, if I had a 2-inch if I had 2 inches, that would mean I'd have an inch on the top and an inch on the bottom. Oh man, you know what I smell? I smell a public input. So what section is this? Oh man, I'm gonna make someone's day. 300.6E. So what we're gonna do? We're gonna do this. We're gonna go to 300.6. Oh, and I gotta log in. It logged me out. Not now. Okay, I've got to go back to TerraView, leave page, submit a public input. It's going to ask me to log in. Or, yeah, no, it's going to be there. 300.6. Oh, man, 300. Someone is going to hate me. 300.6E. And if anybody asks, why would you do this? I'm going to say, we did it together on IAEI News Live. Because I like you guys. This is good stuff, isn't it? So, what's my public input going to be? Wiring methods and materials. Ooh, informational note. Informational note. Wiring methods and materials can be considered as encased in concrete when in 2 inches of concrete, in 50 millimeters, 2 inches of concrete, when what I want to say is, when the 50 millimeters or 2 inches in circles, somebody said in circles over here in the chat, in circles, who said that? Top and bottom and size encased. Encased means encircled, Robert. When the wiring method or material is encircled with 50 millimeters. And why is it that we lead with 50 millimeters and we put in paren the English units? Device is locked. All right. 50. when a material is encircled with 2 inches of concrete. I'll put an informational note in, and I'm going to put in my justification, in my substantiation, I'm going to say the existing language states that see, this one says measured from the top of the corrugated roofing. This one does not include that. Exception number 3, we're going to say exception number 3. Exception number 3 differs from exception number 2 in that the language found in exception number 2, which states the concrete is measured from the top of the corrugated roofing. The concrete is measured from the top of the corrugated roofing. Is not found in exception number 3, in new exception number 3. Simply saying where encased in concrete. Oh, this is good stuff. Simply saying, quote, where encased thick does not indicate that you need 2 inches of concrete on top and bottom of the raceway or wiring method. The concrete must be 2 inches thick, not 2 inches above and below the raceway. This informational note adds clarity for what is intended for this exception. For exception number 3. We hit next. Oh, I got chats going on, but I got to finish this. So I hit next by submitting and hit submit. That should cause a lot of people grief. Save as Word. It's 300.6e. So I go to downloads, open a new tab, 300.6e, 300.6e. PI, what was the PI number? 1600. 1600. I do a Control C and a V. Boom, there we go. All right, so we did a couple things today. Let's take a look at the notes. Wow. I would say on 2 inches on either side, 2 inches, 6, we already talked about that. Hey, Travis Holderman, it's okay. Encased means encircled. Top and bottom equals, and sides, encased. I would say 2-inch conduits would need 4 inches, hence the need for clarity. Steve says, for concrete coverage, I believe it's an ACI 318 has specs for anything embedded such as electrical conduit. There's also a limit of not greater than 1/3 slab thickness. Ooh, interesting. Section Robert, second drawing T, 300.5, notes to table. Close. 300.5, notes to table. 300.5. I'm not seeing the table. I'm not sure where you're going there, Robert. Willie says, so if I'm the inspector, I'm saying you can put a 2-inch right on the dirt of a 4-inch slab and it's code compliant. It's no different than 2-inch slab with a conduit installed under it. That you would have 2 inches on top. So that's my point, Willie. I think that it doesn't really say that. And we say that in exception number 2. We tell you that the concrete has to be on top of it. And we give you the measurement from the top to the top, from the top of the raceway to the top of the concrete, but we don't do the same thing for exception number 3. I love this. But if it's, see, as soon as you start making public inputs, people are like, whoa, I want on this. But if it's related to coverage underground, it could be a 4-inch slab with 2 conduit laying on gravel base, or coverage is at least 2 inches over the conduit. Yep, I would agree with that. What protection is there with a 1/4 inch of coverage? I know, Robert, that's my point. But I could still say it's encased in 2 inches of concrete, because my 2 inches of concrete, my little raceway, I'm done. Freddie B says, I believe the code makes such a reference in relation to buried conduit. Yeah, buried conduit. You may want to look at table 300.7a. 300.7, underground installation. Ooh, note 1, expand table. Where's note 1? A lesser depth shall be permitted where specified in the installation. Cover shall be defined as the shortest distance in inches measured between the point on top of the surface. Yeah, but that's covered. That is cover. They don't use the word encased. Or they have encasement or other proof without concrete encasement. Well, here's what we did. We made a public input. I'm going to do some searching on encased to learn a little bit more about that. Laurel, you may want to look at 307A note 1. Covers between the top surface of any dirt cutter. Yep. Oh, man. Encased. I'm going to have to do a search for encased. Yes, Robert. Thank you, Laurel. Thank you very much. All right, so it's 1:09. I went over time. I enjoyed this session. Is encased a defined term? I don't think so, but you know what, Robert? Let me double check. Chapter 1. Oh, man. I'm probably missing a meeting. Am I? It's probably a very important meeting. No, I'm not. All right, so we're going to search for encased. Encased. E-N-C-A-S-E-D. Or just, how about, well, hold on. Insulated conductor, covered conductor, a conductor encased within material, overhead encased in a polymetric material, concealed, enclosed, concealed, encapsulated, energized, and that is it. Encased is not a defined term. Okay, so we don't have a defined term. And what we have is 2 inches of concrete. And we said the raceway has to be encased in at least 2 inches of concrete. It doesn't say anything about the size of the raceway. It doesn't say how much needs to be on top or bottom. It just says it has to be encased. So I would think that if I only had a 1/4 inch and 1/4 inch and I had 2 inches of concrete, I would say I met the code requirement. Show me how I'm wrong. Oh, we got another one. John, let's talk. 2 inches of EMT has an outer dimension of 2.197, and 2 inches of rigid conduit has an OD of 2.37. So I would say 2 inches, you would not be able to do that, right? So might need more clearance, yes. But now, here's the question with that. If I put 3 inches of concrete, have I met the requirement? Let's take a look at the requirement again. Oh, this is good stuff. You can't make this up, can you? You can see how words matter. I just had that discussion with someone else today. Words matter. 300.6. It says, is it 300.5? No, 300.6. Protection against physical damage. E. Wiring methods and materials shall be permitted in concealed locations where encased in concrete not less than 2 inches. So 3 inches is not less than 2 inches thick. So I could take that 2.37 outer diameter rigid metal conduit. I could make my concrete 2.5 inches, just cover the top and bottom, and say it's encased. Can't see it. I've only got 2.5 inches. I don't have a minimum of, I've exceeded the minimum of 2 inches thick, but it doesn't say that the 2 inches has to be on top and bottom of the raceway. And in the case, and now it could be that the code panel is saying, look, it doesn't matter because it's in a concealed location. But the whole purpose is protection from nails coming in top and bottom because it's in E. Wiring methods and materials installed under roof decking shall be installed to maintain not less than 1.5 inches of separation. So I would argue 2 inches on top would be all that you need. If I have 1 inch conduit and I have 2 inches and I push that conduit all the way to the bottom, I've got 2 inches of concrete on the top. That's all I need. And it's encased. I like this discussion. This is good stuff. But now we know we need some clarity, and I got a public input. Thank you for joining in. Thanks for the discussion and listen to me ramble. And remember, it's just my opinion, right? We all have opinions, and we know they're like another part of the anatomy of a body. So, all right. Thanks, Robert. Thank you for joining in. Thank you for John Thomas for also adding your input. Steve, Robert, Laurel, research in the house. Freddie B, thank you for your engagement. Willie Snyder, always good to hear from you, brother. Freddie B, I'm just looking up through here. I know we had Michael Hofkin joined in. Josh the Sparky was here. So we had Larry Griffith. We had a lot of great individuals, and I really appreciate all of the discussion. Thank you for joining in. Thanks for what you do for the electrical industry. Thanks for what you do for IAEI. Remember, subscribe, hit that thumbs up. Go out there and get your IAEI membership and go purchase a copy. You got to get the membership so you can get a discount on your copy of the 2026 Analysis of Changes. Remember, if you're not found handsome, you should be found handy. Thanks, Robert. Take care. We'll see you guys.